Good morning, my fellow scientists. It's Tuesday, January 3rd, 2017. Grab a cup of coffee, 'cause knowledge is tired. So like any mad scientist, I like to start my day with a little science fiction and blowing things up with lasers. I've already read science fiction. Let's go to the lab. Look at those goggles. Look like a science hipster. Look at that laser cutter go. What you're seeing in those little flashes is not actually the laser light, but actually the backing paper on that plastic burning away. You can't see the laser light because it's 10,000 nanometers. The longest wavelength that humans can see is about 700 nanometers. So it's totally invisible. However, if it did strike your eye, it would probably cause the flesh to melt and possibly burn, and that could very well be the last thing you'd see. Best not to look into the beam. So when I got in this morning, I thought about reading an article with Trump in the title in the New Yorker, but then I realized that that's stupid. And instead, I read the bloggess, because the bloggess is hilarious. She has declared 2017 the year of the pillow fort, because she is officially insulating herself from the pointless crap of life as much as possible. I support this wholeheartedly and intend to follow suit. So welcome to my pillow fort, where we're going to talk about microfluidics, inspired by this late-breaking Langmuir article out of the Microfluidic lab in the United Kingdom. Now what they do is to make a water in oil in water emulsion and then polymerize it. I'm not going to go that far. I just need to make a water in oil emulsion and polymerize it. So after a bit of cutting and gluing, that project I cut out with the laser cutter is assembled and put onto the microscope. At the outlet of the channel, you can see some droplets are already being formed once I start the flow. Here it is through the microscope lens. You can see the orifice from which the water droplets are emerging in the flow of oil. They actually look pretty monodisperse. It's not perfect, and there's still a lot of work to be done. But for our first shot, I'm actually pretty darn happy with how that turned out. So I'm pretty excited about this. The first time I tried to generate droplets and I was able to do it. I think that the technique for generating these microfluidic chips may well be useful going forward, so it could be that if we can find a good way to communicate that, we'll establish some kind of workshop or something in addition to a publication. Tune in tomorrow for more on open source hardware and open source microfluidics.